Okay, in this problem we are going to combine these two series into a single series. There's actually a couple ways of doing this. I will work with the second series first. It turns out there is a way of doing this with using the first series first, but I won't worry about that in this video. So first things first, we're going to change the first series so that it starts on 1 instead of 2. So this starts on 1, I want this one to start on 1. So for the second sum, we're going to let j be equal to k minus 1 so that I get something that starts on 1. And so k would be equal to j plus 1. Let's worry about the boundaries. If k is equal to 2, that means that j is equal to 1. At the other extreme, if k is equal to n, that means j is equal to n minus 1. And so this changes into summation. K equals 1 to n, 2k plus 1 squared. That doesn't change. And then the second series becomes summation j is equal to 1 to n minus 1 of 3 times j plus 1, because k is j plus 1, minus 1 whole thing squared. So that's equal to summation k equals 1 to n of 2k plus 1 quantity squared plus summation j equals 1 to n minus 1 of 3j plus 2 squared after we simplify the inside. Okay, we got a couple of issues before we combine these. First off, that's got a k in it, that's got a j in it, so we've got to fix that. So let's get everything to be the same letter. K equals 1 to n, 2k plus 1 squared. Then over here, let's change the j back to k. K equals 1 to n minus 1, 3k plus 2 quantity squared. All right, so now we've got the same starting point, we've got the same letter, but we have an issue, which is that here's an n minus 1. So this one actually has one more term than this series. And we saw that at the top. This had one more term than this series. So we're going to separate off the extra term in the first series. So k equals 1 to n minus 1, 2k plus 1 squared. So that's the series, except I'm stopping on n minus 1. Then the n term, I'll just consider separately, 2n plus 1 squared. So that's off by itself. If I combine these two, I would get the first series. Then the third series, I have summation k equals 1 to n minus 1, 3k plus 2 squared. Okay, now this part is just going to come along for the ride for the rest of the calculation. I will combine these two, however. So these two series now combine. I have the same first term, the same last term, the same letter. So summation k equals 1 to n minus 1. If I square this out, I get 4k squared plus 4k plus 1. If I square this out, I get 9k squared plus 12k plus 4. And then this just comes along for the ride, 2n plus 1 squared. So I'm leaving a lot of space here to indicate that this thing is not inside of the summation. And so I finally can simplify this. Summation k equals 1 to n minus 1 of 13k squared plus 16k plus 5. Then I have the extra 2n plus 1 squared at the end. And if I wished, I could use the formula that we derived in class to actually evaluate this. That's not asked in the problem. The problem only asked us to combine them into a single series. But if we wished, we can actually use the formulas that we derived by induction in class to actually simplify this series.